I always imagined Pelleroi in a resort-like environment, in a natural environment, in the city. I always thought of birds chirping and sunlight and clean air and happiness. That's the picture I have in mind. It's at the gateway of the new Mumbai, where all the new infrastructural developments and new buildings are coming up. That's the happening location of Mumbai. The architect, Naushad Talati, it was his dream to build a building of such proportion. So he had this brilliant idea of the octagon and angled the views, and I said, wow. So it was like love at first sight.
The owner in this particular case always kept asking, what is the best that's available anywhere in the world, and said, okay, why can't we adopt it here in India on this particular building? And that led to all these different innovations in design and technology.
Excavation was a huge task. The overall excavation volume in this plot was 150,000 cubic meters, out of which 50% was in the soft soil, filled up soil and marine clay, and remaining was weathered rock.
We knew it was going to be a challenge designing foundations for this heavier building. So assuming an average pressure of 2 or 2.5 ton per meter square per floor, the pressure that would be exerted by this building on the ground would be on the order of 200 to 25 ton per meter square. This building has a double basement, so we've gone down about 12 meters below the ground, and we've designed the building floor full hydrostatic uplift, that is 12 ton per meter square.
The upper part of the building is apartments. Then we have the amenity levels, and then below that we have the parking. At the top of the amenity level, we have what we call a transfer girder level. We have a very unique transfer girder system in this building. At 9 meters deep, it's the deepest transfer girder system than any major tall structure anywhere in the world.
12 to 13,000 cubic meters of concrete has gone in this network of transfer girders. We chose self-compacting concrete because there was going to be a lot of reinforcement in the transfer girders. Coupled with that, post-tension cables, vertical as well as horizontal inside the girders to control deflection and to make the girders act monolithic.
When you do a very tall building, if you use those low-strength concretes, the sizes of the elements become so large that the usefulness of the space diminishes. So you have to develop higher strength concrete.
Some of the columns are carrying loads as high as 8,000 tons. There are 2 or 3 types of columns which are carrying loads of 12,000 tons.
If you see our whole concrete is like a laboratory, a university, where people are studying, and the latest concrete we developed, M200, is amazing. We end up getting concrete which has never been produced before in this country, and indeed in the world.
We set up our own concrete institute on site. We also have an electronic batching plant to ensure quality control to the highest standard possible.
Worldwide, if concreting is going to be done above 200 meter, it is considered as a big challenge. Every day around 200 to 250 cubic meter of concrete was to be poured. We had to look for high capacity pumps and then distribution system. So design of pressure boom was to be such that it distributes concrete up to extreme end of the building.
I've never seen a lobby of this size in any residential building wherever I've traveled, It's huge, it's awesome.
You can come in your own car, get dropped off or drive up the ramp, go to your parking. So that changes the experience of entering into your residence totally. If I am a resident of Palais Royal, if I have to entertain some of the guests, I can receive them in the lobby like a king arriving into his palace.
We conceived a system of deeper slabs which will give us bigger stiffness to span that large span. We opted for voided slabs which are formed by using very lightweight material such as thermocol blocks.
We have the world's tallest atrium. We would be 200 meters plus.
The atrium came about as a natural feature of the plan, and also the center of the atrium in our Indian context, which we call the Brahmastan, that means the center of the building. As per the Brahmastan, as for Vastu, nothing should come up in that center.
The work of art in this building is the design, but the execution is not a work of art. The execution is a science.
First and most important quality of a construction is the ability to say that you built the building with the tolerances well within the construction industry standards.
Precise setting out and precise construction has been achieved everywhere. The tower itself, we've monitored, we've shown that the top is very vertical above its base. In other words, there's very little lateral displacement of the top from bottom. The top of towers move laterally. They displace from their plumb as a result of cranes working on top and wind loads. Sun on one side of the building pushes a tower away from it. If you like, the whole thing's moving all the time in every dimension, and it needs to be either compensated for or kept in mind.
We have built in a lot of things by design and in the design and in the construction practice, which is highly sustainable.
And the decision was made very early on that there would be a system which was self-contained, that water that landed on the site in the form of rain would be collected and harvested and reused.
We came up with very innovative idea. Those spaces between the girders, we thought that we can convert them into rainwater storage tank, and we could create space of more than 2 million liter water.
All this makes the building highly efficient and highly benign from an environmental standpoint. An octagonal building is almost like a round shape, and the wind does flow very smoothly past it so that the impact on the building is very low. This building has got an aspect ratio which is the height to the least width of 4. What that means is that we have a very stable building.
This is the first time in India a grade 2 immediate occupation building has been made. Probably the first time a residential building in the world is a grade 2 building.
The building has 2 lift courts which we have converted into a spine-like structure, and in addition the framework provided by the columns and beams help resisting the forces of the earthquake.
The architectural design of this building gives us tremendous advantage in terms of fire and life safety. Everything is duplicated, meaning we have a set of elevators, we have a set of staircase, we have protected lobbies. They become kind of a fire tower.
Palais Royal will be the safest building in Mumbai. Anybody who's going to occupy this can have a very comfortable sleep. It's going to be the last one standing, so that's for sure.
In the history of construction in Mumbai, none of the construction sites has ever had this kind of labor force. The safety standards and housekeeping standards we have been able to maintain here can be compared with international standards.
It started first with the owners and the top management being very, very fussy about safety. People would say, we're going to spend so much money every month on shoes and helmets. Okay, we will live with the reduced productivity, but we were not willing to compromise on safety.
There's decent and hygienic labour quarters on site in the lower levels of the tower. When people are looked after in return, they give something back, and I think it's a very decent workplace.
The development of technologies is going to set a standard, I believe, for future construction, and that's one of the things that Raghuveer did very well on this project.
We thought of doing it and we did it, and in that process we gained all the specialization and skill. We had to look for the cranes which were able to work at 300-meter high. Wherever we felt that this machine will be suitable for our building, those were brought to the site. So today, if there is a talk of constructing high-rise building, Raghuveer is very confident.
I think teamwork is the key to success. My role as the facilitator has been more in terms of encouraging each of my team members that dream the impossible dream.
About 30 people sit in the meeting. Everybody concerned. Water supply, electricity, air conditioning, concreting, structural engineering, architects. The whole lot of them are there, and there is a freewheeling discussion.
You are given complete freedom to propose anything and to design anything which suits the best for a building.
Apart from using my knowledge, there was a lot of learning also. And this has certainly left me richer.
We are part of this team which is putting up a first of its kind project in Mumbai and India. It's a matter of immense pride for all of us.
I think it's placing them right up there in the Indian construction industry. They're making big and positive steps forward.
To see that what you imagine is actually physically come up, it's just an unimaginable feeling.
It will be looked upon as the way to do good quality buildings. I think is going to be a standard bearer for construction in India for a very, very long time.
There are a lot of modern construction companies in India, but we have introduced the concept of doing an engineered building in this sector of residential buildings. So we've taken it to a different level.